Good morning, students. This is Mrs. Jones. Here today we're going to be talking about gear ratios and proportions. And one of the things that we're going to look at are the number of teeth in RPM. And the number of teeth in RPM is what's called an inverse proportion, because if the more teeth that you have on a gear, the slower it is going to spin. A smaller gear with less teeth is going to spin faster. So it is in inverse proportion. All right. So if we look at the ratio of teeth, our ratio of teeth for this first one is 10 to 20, but we reduce it kind of like you reduce a fraction. So 10 to 20, 10 would go into both of them, so it would reduce to 1 to 2. And as far as how many times it will turn, that is being solved by an inverse proportion. So how we solve it is we say that the gear ratio is 1 to 2, and this is A and this is B. Okay, I would always put those little notes in there for myself. And then because it's an inverse proportion, when we talk about how many turns it does, we flip it over and we put the A down here and the X, the B, the part we don't know, on the top. We set it up inversely to each other. So we cross multiply and then divide, and we find out that B is going to make 1/2 of a turn. So if A turns 1 time, B will only turn a 1/2 time, which should make sense because I just said before that the more teeth something has, the slower it will turn. So that should make sense. So for the next one, our ratio would be 40 to 10, but we would reduce it just like it were a fraction. So 40 to 10. I know 10 will go into 10, 10 will go into both of those, so I'm down to 4 and 1. So checking how many times things will turn, we got to set up our inverse proportion. And remember, 4 to 1, and I always put a little note out here so I remember which one is which. And then on the right hand side, that's where we're going to put our number of turns. So A is going to turn 1 time, and because it's an inverse proportion, you set it up diagonally from the other A value. And we don't know how many times B is going to turn. So you cross multiply and you divide, and B comes out to be 1/4. So if A turns 1 time, B is going to only make 1/4 of a turn. So let's look at the next one here. This will be 36 over 60, and then we reduce it like it were a fraction. I know that 12 will go into both of those. 12 is going to go into 36 3 times, and 12 goes into 60 5 times. So my proportion over here, when we talk about RPMs, we go 3 over 5, and go ahead and make the little note here, because this one's a little bit different. This one is asking if B turns 1 time. So we set the B up opposite of where it is on the left-hand side. And A is the part that we don't know. So this time we're going to be cross-multiplying this way and dividing by 3. And we get that A will turn 1.67 times. So if B turns once, A is going to turn faster or more, which that should make sense because remember I said the more teeth, that's slower. Smaller teeth should be faster, should make more turns. So if we have multiple gears that are hooked together, how we do a ratio, we can do a kind of like a transitive property kind of thing, but your best bet is to just kind of ignore that middle gear when you're looking at the gear ratio. So our gear ratio for here, for C to A, would be 10 to 10 because we're going to ignore this middle gear. And when we reduce it, I know 10 will go into both. So I'm down to 1 and 1. And this is C and this is A. And they say if A turns one time, I put the A up here, the 1 up here. This one's kind of very simple because it's a 1-to-1. 1-to-1 means that they're doing exactly the same thing. So you don't even really need to do the proportion. But you'll find out that C will turn once. So let's look at one of these examples. If we ignore the middle, if we ignore the idle gear, our ratio from C to A is 5 to 10, which then we reduce it just like it were a fraction. And I know 5 goes into 5 once, and 5 goes into 10 twice. So when we set up our proportion, this is the C, this is the A, and it's asking if A turns one time. So the 1 for the A is going to go up diagonal again because it's in inverse proportion. And we're calculating C. So we cross multiply and then we divide. And we're going to find out that C in this situation will turn twice. Which should make sense because look at A has 10 teeth and C only has 5 teeth. So C would be able to make 2 turns in the time that A makes only 1 turn. Okay, so we're going to move on from that last example. We're going to go over to the back here and do a couple examples in the first section. So we're talking about RPMs, which it's done pretty much the same way. It says a motor drives a shaft with a 36 tooth gear. So this is the driving gear. It's the one that makes the other move, okay? So it's got 36 teeth. Oops. And I'm going to call that a capital D because it's the driving gear. And then I'm going to call this one a lowercase d because it's the driven gear. And our driven gear has 36 teeth, which it should make sense, or should be extremely easy. And our driving gear turns at 120 RPMs. So we put it across from the driving gear, capital D again. We don't know how fast the driven gear goes. We could reduce the, to make our lives easier, we could reduce this ratio down to a 1 and a 1, and that's going to make our life easier. We're going to cross multiply and divide, and find out that the driven gear will also turn at 120 RPMs. Everybody knows what RPM means, right? Revolutions per minute. So let's look at the next one. We have a driving gear with 36 teeth. I'm going to write this over here, so maybe we can make it a little bit clearer of what's going on. And we have a driven gear of 60. That's the ratio. Now, can we reduce that ratio? I think we can reduce that ratio because 12 will go into both of those. So 12 goes into 36 3 times, and 12 goes into 5, or 12 goes into 60 5 times. And this is the driving gear on top, and this is the driven gear on the bottom. So then with our 120 RPMs for our driving gear, the 120 RPMs goes on the bottom, crisscross from the driving gear teeth, because it is a inverse proportion. And we don't know that part up there. That's very awful written. We don't know how many times the driven gear will move. So we cross multiply 3 times 120 divided by 5. And we find out that the driven gear will move at a rate of 72 RPMs. So our driving gear, who has less teeth, is moving faster than our driven gear, who has more teeth. Right? Let's do one more example here. So we have our driving gear is 36, and our driven gear is 84. And I don't know how to reduce those. Like, I don't have anything in my head that I know will reduce quickly, but I do know that 2 will go into both of those. So 2 goes into 36 18 times, and 2 goes into 84 42 times. And I know those are both even numbers, so I know it'll go again. 18 divided by 2 is 9, and 42 divided by 2 is 21, and I think that's the lowest I can get. So 9 and 21, and you've got your driving gear and your driven gear. And our RPMs, our driving gear has an RPM of 120, so it goes across diagonally from the other driving gear. We don't know how many RPMs the driven gear will make, so we cross multiply 9 times 120 divided by 21. And we get 51.4 RPMs will be good enough for us. Okay. I hope this short video helps you understand how to solve for revolutions per minute, and helps you understand that gears work in an inverse proportion, and you set them up diagonally than what you may have done in like a regular math class. You're going to go ahead and answer the questions on the Google quiz. Make sure you hit submit. Make sure you hit turn in. If you have any questions, you can email me at cjones@ictc.edu, or you can email me directly through Google Classroom. All right. I hope you guys have a great day, and I hope to see you back again soon. Thanks. Bye.